Let's prove that these two triangles are similar. Similar means same shape, not necessarily same size. These two triangles are clearly not the same size. According to the instructions, they are similar, but our job is to prove that they are similar. Okay, remember, our last instruction should be what we set out to prove, our last statement. So right in here, we're expecting a statement that says the two triangles are similar. That same statement will be our similarity statement that we're going to put in the yellow box. I'm going to begin with my givens. So I have two congruent angles. How do I know that? Because it's given. Now, let's think about what my options are. By the way, I'm going to take longer to do this than you will because I'm going to be jabbering. But what are my options for similarity? My options are angle-angle similarity, alrighty, we can do this. Angle-angle similarity, side-angle-side similarity, and side-side-side similarity. Okay. The problem with angle-angle similarity is I'm only given one angle. Now, if these had some vertical angles, like two lines crossing, or some kind of overlap, I might have another pair of angles, but I only have one pair of angles that is congruent, and that tells me that I most likely will not be using angle-angle similarity. Okay. Also, I only have two pairs of congruent sides. I do not know anything about the third pair of sides. If these were right triangles, I could find the third pair of sides using the it would be the hypotenuse. I would be using the Pythagorean theorem. If they were right triangles, however, then I would know that these two angles were congruent anyway, and I would use that. So I would still use side angle side, not side side side. So it looks to me like I've eliminated angle-angle similarity and side-side-side similarity. My only possible choice now is side-angle-side similarity. SAS is in the order that we expect. The angle pair, these two angles, will be between the two pairs of proportional sides. Let me go ahead and draw a little picture of my congruent angles. Hopefully I can actually do that. Again, I'm taking way longer on this than you'll need to do. Don't worry about what I'm doing, but I do want to leave you something that's illustrated as a helpful drawing. So when I'm done here, I will have shown you my two congruent angles. And they are indicated over here. And just for grins, I think I'm going to center that. Now, I have two pairs of corresponding sides. I need to show that they're proportional. In other words, I need to show that they form a proportion. So what I'm looking for is AB divided by ED is equal to BC divided by EF. Okay, again, you do not need to do this. You just need to know that it's true, and you're going to claim that it's true in the proof itself. All right, so what's the length of AB? That's 1. What's the length of ED? That's 2. What's the length of BC? That's 2.5. What's the length of EF? That's 5. If you were doing this on paper, you would not be using the horizontal or the angled slash bar, you'd be using a horizontal slash bar. I'm not doing it on paper, so I don't need to do that. Do I need to center this? No, but maybe it'll help you see what I'm trying to do here. Okay, now, is it true that 1/2 equals 2.5 times 5? Well, what I need is a pair of common denominators in order for these to be checked. So if I have the same denominator, and I'm trying to show that the two numbers are equal to each other, then I dang well better have the same numerator. If I have the same denominator on each side of the equation, then I have to have the same numerator on each side of the equation. The common denominator here will be 10. I'm going to multiply both sides by 1. There's 1. 2 divided by 2 is 1. On my left side, in order to make a common denominator of 10, I will again be multiplying by 1. Here's 1. 5 divided by 5 is 1. All right, I think what I'm going to do is, so we can keep track, I'm going to color some of this. Let's bold that and make it orange. We'll do the same thing with 2.5. And let's make our 2 purple, just so it's more visible as you peruse this at your leisure. All right. This quantity in red is 1. This quantity in red is 1. I've multiplied both sides of the equation by 1. You know that you're allowed to multiply both sides of the equation by the same number and keep that number true. 5 over 5 times 1 over 2 gives me 10 over 10. Sorry, 5 over 10. 2.5 over 5 times 2 over 2 gives me 5 over 10. Is it true that these two expressions are equal to each other? Well, it sure looks like it to me. 5 over 10 equals 5 over 10. I would like to put a little check mark there. I think I'm using enough of your patience already. We're 7 minutes in. So let's just accept that what we set out to claim is true, that the two pairs of corresponding sides are proportional. All right, so pairs of corresponding sides surrounding, they have to be on either side of that angle, surrounding congruent angles are proportional. So that's a lot of words. It doesn't fit well in here. I'm going to shrink it down just a little bit. There's no reason you can't make this look nice for the guy who has to grade this, aka me. All right. How do I know that? Well, I just showed it right here. Just going to copy paste that right here. Maybe I'll shrink that a little bit too, so it fits. And then here we go. What did I prove? I proved that triangle ABC is similar to triangle DEF. Where are my triangle signs? I'm going to go get them right now out of Insert Special Characters. And that one's got rounded corners. I like this one with the pointy corners. Do I have to go do Insert Special Characters again? No, why waste your time? Put it right here. Make sure this says similar, not congruent. Okay, that's the statement that is my similarity statement. And so I'm going to just paste that down here. Maybe I'll make it a little prettier by bumping up the size. And how do I know? So this is the most important part here. Let's just go get this out of this text box. Side, angle, side, similarity is my reason for claiming that the two triangles are similar. And we're done. Do I need these parentheses in here? No. You can leave them in there if you feel like it. I'm taking them out because it doesn't really contribute to it. In fact, I could make these a little bigger now. Let's bump up the size on these puppies a little bit. There you go. Again, if you were doing this in hand, you would not use this diagonal, this slash. You would use a horizontal fraction bar. All right, did I set out to prove what I was supposed to prove? Let's go look at the requirements. Prove that the two triangles are similar. It seems that I did. Remember that your last statement should be what you set out to prove. There's my last statement. Triangle ABC similar to triangle DEF. Let's run around here once and see if they actually correspond. So I'm starting over here at about 7 o'clock on the clock face, maybe 8 o'clock on the clock face, and I'm going clockwise. A, B, C. When I do that in the bigger triangle, I better get the same results. D, E, F. A, B, C, D, E, F. Okay. Write a similarity statement. Did I do that? Yes, I did. There it is. And we're done.